For today's video, we're going to be determining if it's a function or not. Now remember, a function means that there's only one output for every input. So I can have several outputs for different inputs. I just can't have several outputs for one single input. So we'll see as we go through the slides, but what you're going to need to do is go into your Summit and click the link. So when you go into features of functions, you're going to go down where it says customer note sheet, and it's going to be right below the one from the other day. So it should be labeled functions or not. And when you click it open, it should say customer note sheet. All right. So when you open it, it should look something like this. Obviously, yours is going to be a little bit different than mine, but it should still have the same words. So, the customers. A certain business keeps a database of information about its customers, which is how things happen. Think about rewards plans. Think about like when your parent goes and pumps their gas and they use their Friars rewards, those kinds of things. So, the first question, it says, let C be the rule which assesses to each customer shown in the table by in the name of his or her phone number, home phone number. Is C a function? So C stands for customers' names. Okay, so I'm going to look at my customers' names and I can see that each customer here has one number. So we're just looking at the customer names. Are there any duplicate names? Absolutely not. We have one Heather Baker, one Mike London, one Sue Green, one Bruce Swift, and one Michelle Metz. So, is this a function? Absolutely, yes. C is a function because it assigns to each customer exactly one phone number. Now, I know what you're thinking, but keep that idea in your brain for the next question. I can see some of you guys going, wait, this doesn't make any sense. Just wait a second, okay? So, the question is actually asking, is there one name in just our customer names? Is each name have one? Yes, there is one of each person. Okay? So, let's flip to the other one. So, if you're questioning what you should be writing down, it should be in yellow for these slides. Yes, C is a function because it assigns to each customer exactly one home phone number. They get one phone number. It doesn't matter what it is. I write at this point, one name, one phone number. One name, one phone number. Okay? So now let P be the rule. So the phone numbers, okay, which assigns to each phone number in the table below. Okay? So the customer name is associated with it. Is P a function? So now looking at our phone numbers, does each person have one number? No. There are two people in here that have the same phone number. Sue Green and Bruce Swift. They have the same 323 number. So this is not a function because it assigns the home phone number to more than one customer. So, which would be Sue Green and Bruce Swift. So thinking about it like this, my X value, right? So now I have phone number being my X value. There's two different sets of X values and they're two different people. Just like in the other one where customer names were my X value and they each had one. Now my phone number is my X value. That's why it says let the rule be assigned. And my X values or my phone numbers go to two different people. Now, I want you to think about like when you got a cell phone, do you think that the person before you had that number? Do you think somebody before you had the number? Absolutely, unless they're just making up numbers randomly, which they usually do, but we'll get later into that. So I want you to keep that in the back of your mind, okay? Keep in the back of your mind how phone numbers are related to if it's a function or not. So the last part here, it says, explain why a business would want to use a person's social security number as a way to identify a particular customer instead of their phone number. So if you don't know what a social security number is, it's assigned to you at birth a specific number for insurance, for medical reasons, for a whole bunch of different things. As you get older, your 401k, if you hear about people talking about that kind of thing is all associated with social security numbers. So do you think it would be easier to have a person's social security number instead of their phone number be associated with them? Absolutely. A company would 100% want to use social security numbers to identify a person because each person doesn't have the same social security number at all. Think about it like phone numbers, like I was saying earlier. If you get a new phone number, somebody else can have your old phone number, or 500 other people could have your old phone number. It just all depends on. So if sometimes when you get those calls where it's like, hey, is Miguel there? And you're like, there's no Miguel here. It's because that person beforehand had that number and went, oh, I need to call Miguel or whatever. And sometimes it's an error, of course, but obviously this would be a lot easier because you can identify that person once with their social security number. You can say, that's you and this is my number. Okay. So we're going to look at the second part here. We're going to interpret graphs. Okay. So I want you to look at F, this F graph right here, this little curved one, and this G graph. Are those functions? Absolutely. Yes, they're all functions. Because if I take my cursor across this line, every input, every X value or domain has exactly one output or range. Right? If I'm running my cursor along here and it hits in two spots, then that means it's not a function. The vertical line test is a great example. That's what we're doing here. So I'm taking my cursor along the G line and I see that it only hits one time at one number. So these are both functions. Okay, we're going to use the graph, for example, by marking specific points to illustrate the statements shown here. So A, B, C, and D. If possible, we're going to label the coordinates of any points that we draw. So what I'm going to do is, what I'd like for you to do is first maybe highlight these in different colors so you can see where we're going to plot these points or where we're going to find these. So, all right, so for this example, I'm going to use blue for A. You don't have to use different colors, but it's completely up to you. So it says I'm going to look at the F graph, which is this curvy line here. Okay, and I'm going to look for my X to be 0 and my Y to be 2. Well, let's see. So I'm actually looking for essentially 0, 2, where it hits on that line or on that graph. So I know that at 0, 0 is here, and oh look, here could be my F of 2. So that's a possibility. So I'm actually going to label it F of 0 equals 2. You don't have to. I'm just going to do that for my own reasoning. So you can label on the graph and just identify by highlighting them and plotting them. So this one right here might look a little bit terrifying to you, but don't worry. It says that when my X is -3, so let's see, it's going to be about right here. Okay. When my X is 3 and when my X is 9, what do all of those be? Well, let's see. When X is -3, it's going to be the same as my F of +3, which both of these are going to be at a 0. So my Y is going to be at a 0. And then this one right here, it says F of 3 is 0 and F of 9 is 0. So my Y is 0, which is this is what it's stating, right? It says if my function at -3 is the same as my function at 3, which is also the same as my function of 9, they're all going to be 0. So realistically, what I could do is write it out like this. I could actually break all of these up and say that they're all 0. And then f of 9 equals 0. Okay, so let's move on to the next one here. Okay, C, f of 2, so at 2 on my f graph, it's going to be the same as my g of 2. So when you see an equation or when you see a problem like this, it means where do they both hit? So it's saying when f of x is, f of 2 equals g of 2, it's going to be right here. It's going to be right where they intercept, which x equals a 2, because that's what it's stating right here. It says f of x2 and g of 2. Okay, so they both intercept right there. Now for letter D. What this is stating is g of x, that function, so function g, is greater than, if you don't remember, that means that this is greater than f of x for when x is greater than 2. So that means we need to see where this is going to be greater than. So remember, x is just a placeholder, so if I wanted to make sure that this was true, what I could do is plug in 4. Is 4 greater than 2? Absolutely. Is 6 greater than 2? Absolutely, 100%. But is a negative 2 greater than a 2? Absolutely not. So I know it has to be more than 2. So I need to have my x values greater than 2. So that means from this point on, it's saying that my function g of x is greater than f of x after this 2 right here. After when x equals 2. And is that 100% true? Absolutely. Look at this. So look, all of these points right here are greater than my f of x. So what I'm going to write here on my little line here that I drew is g of x is greater is greater than f of x after x equals 2. Okay, so just as a recap, the number inside of the parentheses of f of something, g of something, anything like that, is our x value. And what it's equal to is our y value. Because remember, f of x, whatever that is essentially what y is. So that's y. So instead of saying like y equals 3x plus 2, now we're getting used to f of x equals 3x plus 2. Okay, same thing. Just the reason why we're moving to f of x instead of y is because we're going to be looking at functions, not linear lines usually. So now what you're going to do is go to checkpoint 6 and do the next checkpoint.